they deal with the two types of sequences we're learning. So it says that on slide 2, this word is, the way you say it is arithmetic. So the first type of sequence we're looking at is an arithmetic sequence. And like I said earlier, a sequence in general is just a list or a pattern. If it's an arithmetic sequence, then to find the next term, you find it by adding some number. And that number is called the common difference. So that's the 2 blanks on the left-hand side of slide 2, excuse me, adding, and then the common difference. And then later today, and then even more tomorrow, we'll be working with this explicit formula on the right. The explicit formula is not something you need to memorize. It will be given to you. You should use it. There is a different formula for arithmetic versus geometric, the 2 types of sequences we're learning today. So this formula says a sub n, remember that number or that letter that looks like an exponent, but it goes to the bottom. It's called a subscript. So when I read that, I say a sub n is equal to a sub 1 plus d times, in parentheses, n minus 1. So that's your formula that we're going to be plugging into. And then n is going to be the term number, so like 3rd term, 4th term, whatever of the list or of the sequence. D is the common difference. That's the number that you're adding each time to get to the next term. And then a sub 1 is specifically listed in the formula, and that is the value of the first term. So we'll be using this formula a little bit later today. The math in this unit is actually not very hard. It's going to be the notation that's the hardest part. So we'll be starting to work with that today. Right, moving to slide 3. Now we're looking at the geometric sequence. So we only learned 2 specific types of sequences, just the arithmetic and the geometric. Geometric sequences, you find the next term by multiplying instead of not adding like arithmetic. Geometric is multiplying. And then with multiplying, they call that number that you're multiplying by the common ratio. So geometric sequences have a common ratio. Right, and then their explicit formula is listed on the right-hand side. A sub n is equal to a sub 1 times r to the n minus 1 power. And then again, n is still the term number. R is now the common ratio, the number you're multiplying by. And a sub 1 is still the first term. So we're going to start today by just looking at a list of numbers and deciding if that sequence is arithmetic, if it's geometric, or if it's neither of those 2. We are going to work, like I said, with these formulas a little bit today, but we will not finish working with them, and we will continue working with the formulas tomorrow as well. Okay, so we may skip a little bit on slides. We may do a couple problems here and skip around and come back tomorrow and kind of work with it a little more. We'll just see how time is going. All right, move into slide 4. So on slide 4, it is now asking you, there's several kind of examples there, and it's asking us, it says drag and drop to identify each sequence as arithmetic, geometric, or neither. All right, so a sequence or a list of numbers does not have to be arithmetic or geometric, right? It doesn't have to be either of those. So that's why it says it can also be neither. So we're going to just look at a few of these. I'm going to write a couple of them down. 1, 2, 3, 4 is the first one. And then I'm going to write the first 3 down, like if you're just looking at the left-hand column. And we'll do these together, and then I'll let you do a couple. Okay. Now, a sequence, like we said, that is a list, each term is separated by a comma. That's how I know that it's a new term. So like in the first example, I'm going to number the examples from slide 4. They're not numbered. Again, I'm just looking at the left-hand side right now. I will label that this was slide 4 though. So each term again is separated by a comma. So like 1 is term 1, 2 is term 2, 3 is term 3, and then so on, right? They always go in order. Term 1, term 2, term 3, term 4. The dots at the end just mean that it's a sequence that keeps going, right? It doesn't end here. It's not finite. So when you're given a list of numbers or a sequence or a pattern of numbers, the first thing you want to do is decide what the pattern is. So the first one, it's pretty easy to see the pattern, right? It's adding 1 each time to get to the next term. 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4. I could continue the pattern if I needed to. So all it's asking me to do on this slide is identify that this is, because it's adding something, this is an arithmetic sequence. So you would drag one of the arithmetic boxes over to number 1, or to that first problem. They're not numbered. That's all it's asking, but I also want to work a little bit with the vocabulary. So what we found that it's adding 1 each time, that is called the common difference. And we use the letter D for common difference. So we would say, even though there's not a place for you to put this on the slide, just kind of going over it, that the common difference is 1 for this sequence. It's an arithmetic sequence with common difference of 1. Okay. So like I said, we're going to do a few of these kind of together just to go over some of it. The second problem, if you just look below that, you see kind of in a yellow box, 2, 4, 8, 10. Now, it is a pattern of numbers, but it's not arithmetic and it's not geometric. And the reason is, if it was arithmetic, you would have to increase by the same amount each time. Like plus 2, 2 plus 2 is 4, but 4 plus 2 is not 8, right? So it's not arithmetic and it's not geometric, because to be geometric, it would need to multiply by the same number every time. 2 times 2 is 4. 4 times 2 is 8, but 8 times 2 is not 10. So this is neither or neither, however you would like to say that word, right? It's not arithmetic and it is not geometric. So that does not have to be either of those. These are just the two we learn about. All right, and then the third one, -1, comma 2, comma -4, comma 8. We are not adding by anything because we're going back and forth from negative to positive, but it is multiplying. Okay, it's multiplying by -2 each time, right? 2 times -2 is -4. -4 times -2 is 8. Okay. So that's a good question. Someone said, are there more sequences than arithmetic and geometric? There are other types. So like, for instance, there is a famous Fibonacci sequence where like the numbers, this is Fibonacci, where like 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5. You can make any pattern and it is a sequence. But the reason that we learn so much about arithmetic and geometric, arithmetic sequences, the pattern is linear, meaning it increases by the same amount. So we can write a linear formula for it. Geometric is exponential, and you kind of see that in the formula. And so these favor functions that we learn so much about. So these sequences just happen more often that we need them. Also, later in this unit, we will look at series, which are where we add up sequences, and that is used in calculus to find like area under curves, And that's why we learn it. And so these are the two that you'll need for calculus. So that's why we focus on them. So that's a good question. But yes, there are tons and tons and tons of sequences. These are just the ones that are like the most common formulas that we see and need. Okay. All right, I want to look at one more altogether. I want to look at the blue. It's like the second on the right. So it's the fraction one, 5/8, comma, 5/4, comma, 5/2, comma, 5. So sometimes the fraction ones give people the most trouble. So one thing I want to point out, if you ever look at a sequence and you just can't figure out if it's geometric, arithmetic, or neither, right? Hopefully when you look at this, you at least see that it's not arithmetic because it's not increasing or decreasing by like the same number. What you can do, so if geometric means that you multiply by something to get to the next term, you can go backwards and divide and kind of help yourself out. So what I mean by that is I can always do second term divided by first term. So I'm going to do that real quick. Second term divided by first term. So what that tells me is that to get from 5/8 to 5/4, it helps me find that I multiplied by 2 to get there, right? By doing second term divided by first. So now I could kind of go back and check, well, does that work every time, right? So I could say, well, what is 5/4 times 2? Oh, okay, it's 5/2 or 2.5. Make sure it works again, right? Let's multiply 5/2 by 2. So if you get a fraction one that you're really stuck on, or if you get one in general that you're stuck on, you can always do, like if you're checking for geometric, you can do second divided by first. And if it is geometric, that will give you the common ratio. But always go back and check it like we did and make sure that, hey, that number works. It multiplies to give me the next term each time. Okay. Take a second and just finish slide 4 as well. So on slide 5, it says find the terms in the arithmetic sequence below. So keyword in this direction or in these directions, these are arithmetic sequences. So I know that I am adding something to get to the next term. Okay. Now, some people, everyone has a different level of comfort with working with numbers. So some people are able to find these missing terms very, very easily. And some people aren't. So one way that, if you can, what I'm not say a lot in this unit, if you can solve it easier, if you see the answer, then that's okay. Write the answer. But I kind of like to go over just in case there were bigger numbers or they were decimals or something you didn't see. All right, so just a few things working with notation. 5 is the first term, and we would call that a sub 1. Okay, just working with notation. That means in this problem, a sub 1 is 5. Now, they didn't tell me the second term or the third term or the fourth term, but they did tell me the fifth term, a sub 5, is 17. So we're just working with a little bit of that notation. Because it's arithmetic, I know that it has a common difference, which is the number that you add to get to the next term. They could have given me this problem and just said, hey, what's the common difference? They could have given me this problem and said, hey, tell me the second term, the third term, or the fourth term. They could have asked for anything. They want actually all 3 of these, though. They want all the missing terms. So one way you can kind of think of it, to get from the first term to the second term, I have to add the common difference. All right. To get from the second term to the third term, I add the common difference again. To get from the third term to the fourth term, I add the common difference again. And to get to 17, I would add it one more time. So what we've got here is we started at 5, right? And we added 1, 2, 3, 4 common differences. So 5 plus 4 common differences needs to get me to 17. Right, so you can set up a small equation and solve for your common difference. So then we would see, okay, 4D is 12, so my common difference is 3. So I've seen them give us this problem before and just ask for the common difference. Well, you would be done. But that's not what they wanted. They want each of these terms. So let's go back and use the common difference to find it. So 5 plus 3 is 8. 8 plus 3 is 11. 11 plus 3 is 14. And just to check, 14 plus 3 is 17, so it works. All right, so those were my missing terms. Okay. Any questions so far? We actually just did a problem similar to the red box there, like where they gave you the first term and the fifth term and they just want the common difference. That I just wanted to show that's a different way of asking it, right? Giving you in notation, here are some terms, find the common difference. So since we just did one like that, let's actually do the one beside it. Let's do the green box that says given a sub 1 is 5 and common difference is 2, find a sub 4. Okay, let's do this problem. So one thing that I think is really important is don't make the problem harder than it needs to be. So for this problem, it gave me the first term is 5. It told me how much to add to get to the next term. And I know it's adding because it said common difference, D. If they wanted me to do it by multiplying, they would have used R. And we are going to do some of those on the last couple slides, look at geometric problems like this. But I know it's arithmetic because they used D, not R. And all they're asking for is the fourth term. So if this was me and they were asking me this, first term is 5, I'm just supposed to add 2 to get to the next term, and add 2 to get to the next term, and add 2 to get to the next term. And that's the one they were asking for. That's a sub 4, the fourth term. Okay, that's a sub 4. If the problem is that simple, then please just list them out and find it. Don't make it harder than it has to be. Now, what happens is sometimes they won't ask you for the fourth term. They'll ask you for the 40th term or the 100th term. So as the problem gets more difficult, if they're asking for a higher term, you may want to use the formulas that were given. So I'm going to go over this problem using the formula just in case, because when I look at slide 6, I don't see any that ask for a number higher than 9. But I know that it could be on your assignment later. I know that it could be on a test where they ask you for a higher term number. So this is arithmetic. On slide 2, it said there's an explicit formula, which just means a formula that I can write. And it looked like this, right? It said a sub 1 plus d times n minus 1. Right? This is the formula that was given to us on slide 2. So if I needed to use this formula, if they're asking me for a sub 4, that means I'm plugging in n equals 4 into my formula. Everywhere I see n, I'm plugging a 4. Okay, everywhere I see an n, I'm plugging 4 because that's the one I'm looking for, the fourth term, a sub 4. All right, I know a sub 1 is 5, and I know my common difference is 2. So then all I would need to do is find out what this number is, right? 5 plus 2 times 3 is 5 plus 6 which is 11. Okay, so a sub 4 is 11, which we found when we listed out the numbers. So I'm not telling you have to use the formula every time, but if they're asking for, again, like the 100th term, this is going to be quicker than sitting there and writing out to the 100th term, okay? All right, so for this one, again, this was the blue box there. They gave us the first term and the third term. Finding the 7th term, you should be getting that the 7th term is -10. Let me know if you have a question on this one and need to go over it. Okay, so lots of ways to do it. Whenever someone asks me to go over it, I'm going to go over it probably the way I would think of it. So they gave me the first term. They gave me the third term. So the first thing I would do is find the common difference. I already see it when I look at it because it's just skipping one term. It's just the number in the middle. But just in case you don't see the common difference, right, then it would be 14. I'd have to add the common difference twice to get to 6. So 14 plus 2 common differences to get to 6 would tell me that my common difference is -8. I'm sorry, -4. And again, I already kind of saw it, and maybe you did too, because you only skipped one term. So 10's in the middle, right? So I'm subtracting 4. You could either continue the pattern by subtracting 4, or you could set up that a sub 7 is, use your formula, first term plus common difference times n minus 1. And if you do that, 14 plus a -4 times 6 is 14 minus 24, which is -10. Okay. Or again, you could continue your pattern. Find the terms in the geometric sequence below, and it starts with 2. It skips 3 terms again, and it ends with 162. Now this time it says it's geometric, which means I have a common ratio, not a common difference. Similar to last time, I can set up a little equation to solve. So 2 times r gets me to the second term. Times r again gets me to the third term. Times r again gets me to this fourth term, and then times r one more time gets me to 162. So if I wanted to set an equation up, 2 times r times r times r times r is 162. Now, a different way to write r times r times r times r is r to the 4th power. So to solve this, I'd want to divide by 2 first. And then think about, if this was r squared, you would square root both sides. If this was r to the 3rd, you would cube root both sides. Since it's r to the 4th, we're going to take the 4th root of both sides, right? And 4th root, just in case you're not sure, if I'm going to type a 4th root in, I usually type the 4 in first. And then if I hit math, underneath the one that says cube root, it's number 5, it says x root. If you pick that one, then it will become any root that you've already, I'd already typed my 4 in, so it became a 4th root. So I found out that the 4th root of 81 is 3. So r is 3. So to fill in my blanks, 2 times 3 is 6, times 3 is 18, times 3 is 54. And then I could check it. Times 3 one more time gets me to 162. Okay. So just setting up an equation similar, to what we did. Now, all the ones on this slide are missing 3 terms. So all the ones on this slide are going to come out to be r to the 4th. But it could have, if there were only 2 terms missing, it would be a different r amount. So you would just want to count how many times you're multiplying by the common ratio to get there. Okay. All right, and then let's do a couple off of slide 8, just so we can work with some geometric sequences a little bit. We'll just do the first one there. It says we're given negative 1 over 81, comma 1 over 27, comma negative 1 over 9, comma 1/3. All right, and they are asking us to find a sub 7, the 7th term. All right, any way that you want to do this, you have to find the common ratio first. Now, we know this is geometric because we are working under the slide that says geometric sequence. The only thing that could be added to this is if you were just given the list of numbers and they said find a sub 7, you might first have to determine if it's arithmetic or geometric, right? And we did that at the beginning, right? We were given a list of numbers and had to decide that. All right, take a minute and find your common ratio. Remember, if you don't see it right away, you can always do second divided by first and then go back and check and make sure it works. So take a minute and find your common ratio. We should be getting that your common ratio is -3. Again, you could do this term, second divided by first. It gives you -3. And then I always like to go back and check and make sure I'm right. So I would do 1/27 times -3, -1/9 times -3, just to make sure that it works out with the list of numbers. So they're actually asking me to find the 7th term. So you have 2 options, just like you did with the arithmetic ones. I already know the 4th term, so I could just keep multiplying by 3 until I get to the 7th, right? 5, 6, 7, that's all they're asking me to find. So I could keep multiplying by -3 until I get there. And that's fine with me. I want to show you at least once how to use the formula in case you need it though. So the formula on slide 3, because this is geometric, the explicit formula on slide 3 says to find any term a sub n, you take your first term and you multiply by r to the n minus 1. Okay, so if we wanted the 7th term, then we would take the first term, and I'm going to put it in parentheses mostly because it's a fraction and a negative. It's the only reason I'm adding some parentheses there. So first term times r to the n minus 1, and we're finding where n is 7, the 7th term. N is the term number. So 7 minus 1. Okay, and you're going to type it in exactly like that. Only the -3 is being raised to the exponent. Okay, so -1 over 81 times -3 to the n minus 1, and we get -9. All right, and again, you could have very easily just done 1/3 times -3, -1 times -3, 3 times 9. You could have worked it out, by your list, or you can use the formula. You kind of get to pick which one you think is going to take you less time, depending on what they ask. No, you can raise it to the 6. I just don't simplify. I mean, I type it straight in the calculator. 7 minus 1 is 6. You can definitely type that in for sure. Okay. Any other questions?